Hello there, Mr. Sutton bringing you this IM23 Honors 3.6 homework solutions on Introduction to Circles. For numbers 1 through 8, we're trying to match these symbols with the words that best describe them. So we're looking at B here, point B. That's over here. Now there's a few things happening at B, but the big one, this is a point of tangency. This is a point where a tangent line is hitting the circle. So G is the best answer out of all those. And then we have line BH, that's this line right here. This is a tangent line. It's also a common tangent, so H would work here. Also F. But if we're only allowed to use the letters once, then we might as well use a common tangent because there are no other common tangents in this diagram. All right, now, let's take a look at segment AB. That's this segment right here. Since it's just a segment and not the line that goes through here, this is a chord. It goes from one end of the circle to the other, but it's not the diameter, so that's C. And then line AB, it's the same segment, but now it's the line that goes through there. That's going to be a secant line because it actually goes through the circle. Next, we take a look at line AE. That's this line right here. That is just a tangent line. So F, because that's just touching the circle once here. And then point G, that's this point right here. That's the center of a circle, so choice A for that. And then segment CD, that's this little segment right here. That's the radius of the circle. It's half the diameter. It goes from the center to the circle, so that's B for that one. And then BD, that's going all the way across the circle through the center. That is a diameter. So that was D. For number 9, we're trying to figure out whether this AB segment is tangent to the circle here. Easiest way to do that, since we know the radius of a circle and a tangent line meet at a right angle, if we can show that this is a right triangle using Pythagorean theorem, then we can show that this AB is actually a tangent line. So let's set up our Pythagorean theorem. So we've got the two legs of what we're hoping is a right angle. So 3 squared plus 4 squared, we're seeing if that equals 5 squared. And if you know your 3, 4, 5 right triangle, you know right away that this is going to be a right triangle. But just proving it rigorously here, we've got 9 plus 16 and 25. 25 does in fact equal 25, so yes, this is a tangent line because CA is perpendicular to AB. So that's a big yes for that one. For number 10, we're trying to determine if segment AB is a tangent line to this circle. Fastest way to do that is to see if the radius and the supposed tangent line here meet at a right angle, which we can figure out by seeing if this is a right triangle. Pythagorean theorem's our best bet on this one. Now, the A squared and the B squared, one of those sides is going to be 48, so we've got 48 squared. The other side is this diameter here. So this is actually going to be 10 plus 10, or 20 squared. And then we're seeing if that adds up to 52 squared. So for this, I'm going to need the calculator. I know 20 squared is 400. The rest of it, though, I'm not so sure about. So on one side, we've got 20 squared plus 48 squared, which adds up to 2704. On the other side, we've got 52 squared, which is also 2704. Well, since it comes out the same on both sides, we know then that AB and CB are perpendicular. That should be CB there, not CA. So since those are perpendicular, that means we have a tangent line. For number 11, we're trying to find the value of R. We can set up Pythagorean theorem to solve this one because we have a right triangle. So that's R squared plus 9 squared equals, now for the hypotenuse, we have R plus 6 to get that whole third side, and that's going to be squared. Let's simplify this. Remember that when you're squaring a parentheses, you're really multiplying it by itself. So you could FOIL it out, or you might know the shortcut for expanding that. Either way, this comes out to R squared plus 12R plus 36. And then we can subtract an R squared from both sides. Subtract 36 from both sides. That'll be 45 on one side there. Dividing by 12, well, let's see, 12 goes into 48 4 times. This is like a quarter less than that, so 3.75 for r, or you can do it on the calculator. For number 12, we're trying to find the value of r. Since we have a right triangle, we'll use Pythagorean theorem. So we've got r squared plus 6 squared equals, this will be r plus 3 quantity squared, which is really r plus 3 times itself. You could do that and FOIL it out, or you could just expand it from here. Either way, that comes out to r squared plus 6r plus 9 on the right side. We can subtract r squared from each side, and then 36 minus 9, that'll be 27. Divide both sides by 6 to isolate r, and that's going to be, let's see, 4.5. For number 13, we're told that B and D are points of tangency. So we've got two tangent lines coming from the same external point. We're trying to find the value of x. Now we know in this situation that these tangent lines will have the same length, so we can write 3x plus 10 equals 7x minus 6. Subtracting 3x from both sides, that's 4x. Add 6 to both sides, we've got a 16. Divide by 4, we get x equals 4. On number 14, we're given these two tangent lines from the same external point, and we're asked to find the value of x. Since we know these tangent lines are going to have to be equal, let's just set those two expressions equal to each other. Now this is going to set up a quadratic situation. Normally we would try to get everything on one side and either factor or use quadratic formula, but if you start moving things around, you're going to see that these 4x's cancel each other out. Since you're not going to have an x term in there, that means you can just solve this by regular square rooting. So let's cancel out those 4x's, and I'm going to add this 4 over to the other side, giving me 3. Divide by 3 now. We have x squared equals 1. And then square rooting both sides. Normally I would get plus or minus 1, but I'm just going to take positive 1 in this case, because if I had negative 1, then AB, this segment up here, would have a negative overall value, which doesn't make sense geometrically. So we'll just stick with positive 1.